Welcome to the fourth technical lecture for the political economy of the environment. Today we're going to explore incentive-based regulations, which use markets to reduce pollution and minimize control costs. We'll discuss why economists often prefer these types of environmental regulations, as well as some of the drawbacks of incentive-based regulations. Assume that there are two plants, plant A and plant B, which both emit gunk as part of their production processes. The costs of reducing gunk vary for the two firms, and they are given by the following equations. For plant A, MC equals 12 minus 2A. And for plant B, MC equals 12 minus B, where MC is the marginal cost of reducing gunk in dollars, and A and B are the amount of gunk emitted by plants A and B in tons per day. We can graph plant A's marginal cost of pollution reduction as a function of the amount it pollutes. This line has an intercept of 12 and a slope of -2, which looks like this. The line intersects the horizontal axis at 6 tons, which means that plant A will produce 6 tons of gunk per day if there is no cost to pollution. Plant B's marginal cost of pollution reduction looks like this. If there is no cost to pollution, plant B will produce 12 tons of gunk per day. Note that the marginal cost of pollution reduction could also be viewed as the marginal benefit of pollution, or the demand for pollution. I will refer to it as a marginal cost of pollution reduction, to be consistent with Goodstein's textbook and your homework. Suppose that the plants are both located in Springfield, you pick the state, and that the residents decide they can no longer tolerate more than 12 tons of gunk per day. How should the city reduce pollution from 18 tons to 12 tons per day? There are infinite possible solutions. Plant A could reduce its pollution by 0 tons, and plant B could reduce its pollution by 6 tons. Alternatively, plant A could reduce its pollution by 6 tons, and plant B could reduce its pollution by 0 tons. Or the firms could share the burden of reducing the amount of gunk they emit. What is the best solution? The cost-effective solution would be for the two plants to emit a total of 12 tons of gunk per day, in such a way that the marginal cost of pollution reduction is the same for both plants. In other words, two equations must hold. A plus B must equal 12, and 12 minus 2A must equal 12 minus B. By substituting 12 minus A for B, we see that A equals 4 and B equals 8. For both plants, the marginal cost of reducing a ton of gunk is $4. Graphically, the cost-effective solution looks like this. Why is it cost-effective for plant A to reduce its gunk by 2 tons and plant B to reduce its gunk by 4 tons? Well, imagine that the city mandated that plant A emit only 3 tons of gunk and allowed plant B to emit 9 tons of gunk. This would be inefficient because it would raise compliance costs for plant A by more than it would lower compliance costs for plant B, as you see by comparing these red trapezoids. Cost-effective regulation requires that the marginal cost of environmental protection be the same across firms. Now the question is, how can the city of Springfield regulate both plants to reduce pollution to 12 tons of gunk per day? If Springfield knew the marginal cost of pollution reduction for both plants, then the city could make the same calculations we just made and mandate that plant A reduce gunk to 4 tons and plant B reduce gunk to 8 tons. But how would the city determine the marginal cost of pollution reduction for both plants? It could ask the managers of each plant to calculate the marginal cost of pollution reduction, but the managers would have not any incentive to provide accurate information. In fact, both managers would want to exaggerate the cost of reducing their own pollution, so that the city would force the other plant to achieve a larger share of the total gunk reduction. This is one of the main arguments for incentive-based environmental regulations. Incentive-based regulations require less public knowledge about the variation in plants' marginal costs of environmental protection. One possible solution would be to impose a gunk tax on the two plants. By forcing the firms to pay the city for every ton of gunk they emit, the firms will have an incentive to reduce their emissions. Indeed, a $4 tax per ton would lead Plant A to reduce its pollution to 4 tons, and Plant B to reduce its pollution to 8 tons. Why? Consider Plant A. Reducing its pollution from 6 tons to 4 tons would cost it $4, as shown by the blue triangle. But it would save it $8 in tax, so Plant A has an incentive to reduce its gunk. It has no incentive to reduce its gunk below 4 tons, because a marginal cost of pollution reduction exceeds the tax, so it will emit 4 tons per day and pay the city of Springfield $16 in tax, as shown by the red rectangle. The situation is similar for Plant B, which reduce its gunk by 4 tons and pay $32 in tax. Economists often point to the double dividend that comes from taxing negative externalities. These taxes can lead to an efficient level of environmental degradation, and they can raise funds for public goods. In this example, we've again assumed that the city knew what level of tax is needed to reduce gunk to 12 tons per day. This is unrealistic because the managers of the plant have no incentive to tell the city about the real marginal cost of pollution reduction. But in the real world, without perfect information, the city could estimate the correct tax and then adjust it as necessary over time. For example, suppose the city initially instituted a tax of $2 per ton of gunk. Then Plant A would emit 5 tons of gunk per day, and Plant B would emit 10 tons of gunk per day, and the government would raise $30 in tax revenues per day. Since pollution levels are still above the tolerable level, the city could raise the tax until the pollution is reduced to a total of 12 tons per day. An alternative to imposing a tax would be requiring plants to obtain tradable permits for each ton of gunk they emit. This type of incentive-based regulation lets the government decide exactly how much gunk will be emitted, and it allows firms to determine the cheapest way to reduce pollution. If the government auctioned off 12 permits each day, they would auction for $4 each in a competitive bid, since the marginal cost of reducing gunk below a total of 12 tons is $4 for both firms. Plant A would purchase 4 permits and pay the government $16, and Plant B would purchase 8 permits and pay the government $32. This outcome is identical to the $4 gunk tax in the previous example. The main difference is that by placing a cap on the total amount of gunk that can be emitted by the two firms, the city of Springfield can ensure that total gunk levels will immediately fall to 12 tons per year, without knowing the marginal cost of both firms. Incentive-based regulations are not always a perfect solution for environmental problems. The readings discuss how they can lead to problems with hotspots. Incentive-based regulations can also require costly monitoring. Speculation can also lead to volatility in the price of permits. Although governments can theoretically raise money by auctioning off emissions permits in a competitive bid, firms often lobby governments to give them the permits for free. In these cap and giveaway schemes, the government places a cap on how many tons of gunk can be emitted each day, but it then gives the permits to firms, usually based on their historical emissions. Cap and giveaway schemes can still lead to cost-effective pollution reduction, since firms will still trade permits to minimize the compliance costs. But the government will not raise any money in the scheme, and there is no double dividend. On your own, consider a cap and giveaway scheme for our example. Let's say that Springfield decides to cap total gunk at 12 tons per day, and it gives 6 tradable permits to Plant A and 6 tradable permits to Plant B. Will either firm sell any of its permits to the other? What will be the price of the permits? Will the scheme make either firm better off? Why might Springfield implement this cap and giveaway scheme? Thanks for listening to your 4th technical lecture on the political economy and the environment.